Hello everyone, this is the video lecture for Calculus 3, section 13.4, Velocity and Acceleration. I'm just going to give you the very basic formula of both of these. You have an r, and then you have v, which is r prime, and then you have an a, which is r double prime. There you go, there's your formulas. Alright, let's do some math. 13,4,003. So they give me an r, which is equal to, hold on here, negative half t squared 2t. And they want, well, everything. So v, which again is r prime, find the derivative. 2 comes down, negative t, and a 2. Doesn't look good that way. Okay, there you go. My a is now r double prime, so negative 1, 0. Cool. They also want magnitude of v, and so you would just go t squared plus 4, essentially. That's easy. And if they're asking about a graph, notice it's 2 dimensions, all that kind of stuff. It's basically a sideways parabola, and we have an a going in, we have a v going out. There you go. Ta-da! Next one. 13,4,009. This is now 3 dimensions. T squared plus t, t squared minus t, and then 6t cubed. R prime, sorry, v is equal to, got 2t plus 1, 2t minus 1, 3 comes down, 18t squared. R double prime, again that's my a, I got 2 comes down to make a 36t. And of course they're wanting to have magnitude of v, magnitude of r prime, so you just do a big square root thing. Because WebAssign does not need to be simplified, honestly, at this point, I would probably just leave it like that. Actually, that's how I did it on my paper, so there you go. Next one, 13,4,020. So this one's a little different. It says the force required for a particle to move of mass m. So I have a mass m, like just kind of like m, like a slope m. So we're going to use that, mass m. They're looking for the force, and they give me this path that the particle is moving on. T cubed, 6t squared, t cubed. Okay, I'm not going to draw that. It's not even worth it. What's my formula? Well, you know that F equals ma, yeah? So what if I just did F equals ma? Now notice that m cannot be a vector, because then you'd have to do dot product or cross product or something like that, and your mass is not changing. Your mass doesn't, you don't have like more x mass than y mass. It's just a mass. It's just a number. So here we're just going to assume it as a mass, a number. That's it. But I can find my a, because that, as you know, is r double prime. So that's what we're going to do right quick. So, oops, let's do one at a time, of course. 3t squared, 12t, and 3t squared, r double prime. Sorry if it looks like I'm going up. I'm trying to compensate here with my drawing tablet. 12, 60. Okay. So this is definitely important. What I'm going to do is my F, my answer here is m times all the stuff. You know how to finally answer it? You distribute your m, and this is honestly your answer. 6mt, 12m, 6mt. There it is. You're done. That's it. So not too much work, and it's kind of a little different. This section actually is a little smaller, but not less difficult. There's actually the problems there are word problems, so a little bit of more work there. But I think there's fewer problems. But regardless, we're going to talk about a projectile for this one. Projectile. It has an initial speed of 210 meters per second. Cool. It has an angle of elevation of 60 degrees. So that's how high it was like blasted off. Just so that you know, G is equal to 9.8 meters per second squared. That's your gravity. And go. Well, there's a formula for this, but let me just quickly show you what's going on. We're doing this. And so that initial angle there was 60 degrees. And it blasted off initially at 110 meters per second. And so they're going to want to know how high did it go, how far did it go, all that kind of stuff. So that's our goals, so we're going to find all that stuff as we go. So what's the path then? Let me give it to you and I'll explain it here as I go. So it's 210t cosine of 60, and then 210t sine of the 60 minus 1/2 9.8 and then t squared. Okay, so what's going on here? Well, essentially, I'm saying my initial velocity times t, but then in its direction, cosine and sine. So notice that the t there is basically saying it's going to continue. It doesn't. Its initial velocity is this much, but it will continue to go for a while. Remember that this is simply just saying x and y. So I'm saying my x position is not always just 210. It's 210 times the time it takes to get there. So 210 times however much time it is. This part over here is your gravity. Let me try to make that look a little bit better. This over here is your gravity, essentially. I can't spell gravity, but you get the idea. And that's just a constant. It's not a constant in the sense of a number, but it's always going to be there. There you go. Clarity. So part A, they want the range of the projectile. So it's launched off, how far will it go? Like again, what are they wanting? They're wanting to know that distance there. It's supposed to be at R. There you go. So what's that range? Blasting off and landing later. Well, basically here's the thing. You have x and y, and your y value here is 0. That's a key component. So you're saying all this is equal to 0. What's sine of 60? Isn't it square root 3 over 2? Then 1/2 of that is 4.9. I'm saying this equals 0. Notice that I can factor out a t. That really is what saves us here. Otherwise, that would be very difficult. So they're saying that it's you're at 0 height at 0, but that's the default trivial answer, I guess you can say. And here we can solve for t. So move it over, divide, all that kind of stuff. I got 37.11537.445 seconds. Now this is not your answer, but it's important to use. That's how long it took to get over there. So it's in the air for like 37 seconds. It's a pretty long time. So then what's my x over there? What's my x value here is what they're actually wanting. If this was 0, and then over here, what's that distance? Well, it'll just be the x value. So x is equal to what? Well, 210 t cosine of 60. That's going to be a half, by the way. Well, we know what t is, so I can put that in now. I'm just going to put the shorthand here. And there's a half. Do some math. 3897.114 meters. There you go. I would put the entirety of that in there, by the way. So this is my range. That's how far it went, which is pretty far. Okay, part B, they're now saying what's the max height? Again, what is that? Well, when they're projectiling it, they're saying how high did it ever go? How high was it up in the air? And notice that if this right here was at 37 seconds, where would this guy be? Well, it's at 37 over 2 seconds. It's halfway. Halfway is the maximum, and that's actually a key component of this basic style that we have for projectiles here. So then I'm going to take my 37.1153 divided by 2, and I get 18.55768, again, seconds. Okay, so that's going to be important. Again, not my answer. It's not saying when is my maximum. It says how high. Well, that's a y value. They're wanting to know what's the y value, how high it went. Well, we have a function for y. Let me go ahead and write it back out here. There you go. And I know what t is, so I'm going to, plug it in, and get some answers here. And y equals, let me just go ahead and give you the answer, 1687.5 meters. So that's, again, that's the max height. Cool. Part C says, what's the speed at impact? Whenever it's coming in, how fast was it going there? Well, let me tell you, it was going up at some initial velocity. It's going to be coming down at that same initial velocity. Literally, there's your answer, 210 meters per second. Very fast, very easy. You can test that with like tossing a baseball in the air and all that stuff. I don't know. Okay. 134039. So now I have an R, which is equal to cosine of t, sine of t, t. And they want to know what is a sub t and what is a sub n. So these are your accelerations in the tangential and normal components. It's blah, blah, blah. Let me just go ahead and give you the formulas. So a sub t, or a of t, is v dot a all over magnitude of v. And a sub n is going to be the magnitude of v cross a divided by the magnitude of v. Okay, so those are my formulas. That's what I'm going to use. Well, here we go. So r prime, go ahead and just take derivatives here. Cosine is going to go to a negative sign. Sine is going to a cosine. T goes to a 1. R double prime. Sine will go to a cosine. Keep the negative. Cosine goes to a sine now. Negative sign. That's a 0. One thing to note along the way. Oh, that's interesting. One thing to note along the way, because we'll be using it. What's the magnitude of r prime? That's in both formulas. Might as well do it. So square root of, sine squared plus cosine squared, and then plus 1 squared. This part right here makes a 1. So then we got 1 squared plus 1 squared. Well, heck, it's not just 1 squared, it's just 1. But anyways, regardless, we got square root 2. So that's going to be used in the denominator of both of these. Okay, now we've got to go and find the other ones. So v dot a, again, I'm going to dot product these two right here. And so dot product is going to yield a scalar, by the way. So I've got a negative sine times a negative cosine plus cosine, times a negative sine. And then I got 1 times 0, but that's just going to be a 0. You don't need that. So I've got a negative, actually it's going to be a positive sine cosine here. But here it's going to be a negative sine cosine. And you know what happens here? Those guys cancel and make a 0. So your AT is going to be 0 divided by square root 2, which is just 0. So there you go. There's your answer for part A. And now let's find V cross A, and then I'm going to do the magnitude of that. So we already have them up here. So let me rewrite them, because it's going to be a little interesting. Trust me that I've gotten this wrong. I had to go and like double check all my work and all that stuff, because there's a lot of moving parts. Anyways, always a 0. Sine and sine will make a sine squared. 2 negatives make a positive, so sine squared, that's a k component. Anything times 0 is a 0. Cosine and cosine makes a cosine squared, but that's a negative k component. 2 negatives make a positive. Cosine squared, k component. Always a 0. Anything times 0 is a 0. 1 times anything is itself. And so this down here is going to be a positive j component. So you're honestly going to get a negative cosine tj component. Right here, this is a negative I component. 2 negatives make a positive. So it'll be a positive sine ti component, and then always a 0. So my vector turns out to be, I've got sine t, negative cosine t, and then I've got this stuff for my k component. Well, what's sine squared plus cosine squared is a 1. Kind of interesting how that works. Well, I need the magnitude of that thing. So the magnitude, then I got sine squared, cosine squared, and then 1 squared. Well, this stuff yet again, that's a 1. So I've got basically 1 plus 1 is a square root 2. Again, that's the numerator. So I got my numerator, and like I had said earlier, I have my denominator also. You know what happens? It makes a 1. Ta-da! Okay. I've got one last problem, and I'm only going to talk about it. I'm not going to actually do it with you completely, but I'm going to talk about it because, well, I think a little bit of explanation might be helpful. So this is the catapult siege. I don't spell catapult very well, do I? The catapult siege. I can't spell siege either. There you go. Of a medieval city and all that stuff with the castles and all that kind of stuff. Anyways, you'll understand it when you start reading it. Okay, what's going on is that there's this city that has a big wall around it, and the armies are trying to toss catapult stuff in there. So anyways, it tells you the dimensions of the city here. It's 500 meters wide, and it's 15 meters. Oh, let me put that on the other side over here if that's okay. And it's 15 meters high. So not to scale, but you can only get, the army can only get 100 meters away without getting pelted by arrows and whatnot. So they're 100 meters away, and they got their catapult, and they're going to toss in stuff. But notice how I'm arcing this here, or all the way over there. What I'm getting at is that they're trying to get it inside, but not over it. You don't want to go over it, okay? And you don't want to go under it. So there's got to be just and the catapult doesn't change V0. The V0's fixed is a constant. I think they even tell it to you. V0's always going to be 80 meters per second. But, and of course gravity's always going to be the same as well. So gravity's 9.8 meters per second squared. What the thing is that you can change is the angle. So they're saying, what are the angles that would get, in there? Let me attempt it with a different color here. So I can go like this, and I can go like this. So there's some angles. You can see kind of like my two angles there. And that's going to be your domain for that one. But there's also another style that could happen here. So your answers are going to actually have 4 numbers, not just 2, because that's one way. But notice here, let's just do a little This is a little note that I have on my sheet here. Let's just say that you're tossing things or whatever at like a bullseye, okay? That's the worst bullseye ever. Okay, so you're wanting to hit this bullseye. Well, you can like throw a dart directly at it, right? So your angle is going to be very small angle. Or you can throw it way up in the air and it comes down like this, okay? I know that sounds silly, but what I'm getting at is that you have a smaller angle answer and you have a bigger angle answer. So you got this small little angle and you got a huge angle. And that's the same for here. You have this range, not small or bigger. No, this is that direct shot, okay? The alternative is that you're trying to lob it in. So you could do this or this. So that's your big angle answers, okay? So you'll actually get 1, 2, 3, 4 different answers for, again, the short angles and then the long angles. Let me go ahead and give you the answers for what I had, my personal one here, so with the numbers that you saw. So my answers are, here we go, 13.0 to 36.0 union. So those are my shorter angles. Union, 55.4 and 85.5. Okay. And again, these are the bigger ones. So this is, like, I would say those are my direct shots, like throw it directly at it. And here, these are like the lobs, like you're lobbing it over. And so you're trying to find, again, a minimum and a maximum, and then a minimum and a maximum for each one of those. I know that sounds like a lot of work, but it comes just down to, again, your vectors, and it's going to be V naught T cosine theta, V naught T sine theta minus 1/2 GT squared. And so you know that your Y value must be, what's your Y value here? It's going to be a 15, isn't it? Because that's how high it is right there, 15. And your X value, you would have a 100, or, so that's 100, or you would have 600. And so then you can start solving for thetas and stuff like that. You can find your T, solve for theta, et cetera, et cetera. This is actually a theta right there, sorry. That's a theta, because that's a theta. Okay, blah, blah, blah. Try it out. And, of course, if you got questions, you can let me know. All right, thank you very much, guys. Have a great day.